Hi students, in the basics of the microprocessor and microcontroller subject, we are going to see different definitions. So initially, we are going to start with the definition of the microprocessor. This is the initial definition of the microprocessor subject. So what is meant by microprocessor? So generally, these definition we are going to classify into 4 points here. So in different textbooks, they are represented in different definitions. The combination and which the overview which is given by the 4 points here. That means initially the first point is microprocessor is a semiconductor IC fabricated or manufactured by using VLSI technology. It incorporates the functions of the CPU. The CPU contents are ALU, that means functions of the CPU, ALU, control unit and memory. The fourth one, it performs operation like instruction cycle. So instruction cycle is a group of 3 cycles, the combination of 3 cycles. First one is the fetch cycle and decode cycle and also execute cycle. The representation in motherboard, the microprocessor representation is like this. This is the master microprocessor. So outside the every corner which indicates the physical pins. That means those physical pins, with the help of those pins we are going to sharing data transfer from the various sources. Here this is also microprocessor representation. Here we are using VLSI technology. Here also we are going to identify it, that means VLSI chip, VLSI ARM processor. A little bit introduction about these points. First of all, microprocessor word can be classified into 2 groups. Here micro is simply it is represented as a small processor. That means every time we are going to consider as a small processor. What is meant by small processor? The occupying area of this IC in the motherboard is very less. That means it is occupying area is very small. So that always we are going to calling as a small processor. Micro in the sense sometimes we are going to represent it in 10 to the power minus 6, but not, this is not a processor speed. Microprocessor always is processing the speed of 10 to the power of 9. That means nanoseconds. Nanoseconds, this microprocessor will process the different operations. Coming to the first definition, first point of the definition, microprocessor is a semiconductor IC. What is meant by semiconductor IC? The general representation of the semiconductor or definition of the semiconductor, where semi means of conductor. The material always we are going to classify into 3 categories: insulator and semiconductor and also conductor. Suppose if you take any resistivity property or voltage property or charge carrying property or resistivity, that means current property. Any property, if you take any property, these properties are lies in between insulator and conductor, that is called a semiconductor. Our definition we are going to say like this, that means the resistivity properties lies in between insulator and conductor, that is called semiconductor. Like this, voltage properties lies between insulator and conductor, that is called semiconductor. Like this, we are going to say any one of the properties lies in between insulator and conductor, that is called semiconductor. Coming to the second point, IC. That means IC means integrated circuit. Integrated means then in general representation, mathematical approach, suppose the limits over a 0 to 5, which indicates what is the general meaning of this one. It means we are going to adding all those values. That means we are summing all those values. Integration in the sense we are going to summing. Like this integrated circuit, the circuit which integration of all the active components. For example, diode, that means a transistor or a field effect transistor. These are the examples of the active components. We are going to adding all those components or summing all these components, or summing or adding or tightening or fixing. That means embedding. All these terms is represented as a integration. Integrated circuit means we are adding, tightening, fixing, summing, togethering, joining. All these names which indicates, that means integration. Integrated circuit means it is a combination of all those active components. So coming to the second point, fabricated by using VLSI technology. So VLSI technology. VLSI technology means this is a present day technology, that is 4th generation technology. Previously we have first generation, second generation and third generation and fourth generation and fifth generation, like this. In first generation SSI and second generation MSI and third generation LSI and fourth generation VLSI and fifth generation ULSI. Coming to the 6th generation, GSI. So SSI means small scale integration, MSI means medium scale integration, LSI means large scale integration, VLSI means very large scale integration, ULSI means ultra large scale integration, GSI means giga scale integration. VLSI means generally we are going to adding all those active components nearly 10 to the power of 6 to 10 to the power of 8 roughly. We are going, millions of the transistors we are going to adding inside the chip. So this is the 4th generation IC we are going to using present days. So very large scale integration we are using present days. So that this is a VLSI. See here the inside the chip we are going to represent, that means VLSI ARM processor like this. VLSI technology we are using to fabrication of the all those ICs. Coming to third point, it incorporates the functions of the CPU. That means functions of the CPU or contents of the CPU. In this case, we are going to see arithmetic logical unit, control unit, and memory unit. The combination of these three parts is called as a CPU. So coming to the digital block diagram of this computer, inside central processing unit, this green color box. So this one, the complete box which indicates CPU. Inside CPU, central processing unit, control unit is there, arithmetic logic unit is there, memory unit is there. So let us see a little bit introduction about this ALU. What is meant by ALU? What is the use of this ALU? What is the use of this ALU inside the processor? ALU is the execution block. Without ALU, you cannot execute any operations. So that without ALU, there is no processing, there is no executing. So that ALU always which performs arithmetic operations, logical operations, and also it will perform shift and rotation operations. Arithmetic operation means addition, subtraction, multiplication, division, and logical operations AND, OR, XOR, XNOR gates are there. So those are the logical operation. Shift operation means shift left, shift right, and also rotate left, rotate right. These are the operation is performed by using ALU. Not only these operations, it will perform the data transfer operations also. So coming to the little bit one more introduction, if ALU size is 8-bit, that means the processor is 8-bit microprocessor. 8-bit microprocessor. If it is a 16-bit, the processor size is 16-bit microprocessor. You can directly say that is a 16-bit. If it is a 32-bit ALU, it is called a 32-bit microprocessor. If it is a 64-bit ALU, that means simply you can say that is a 64-bit microprocessor. That means what will happen if it is a 8-bit microprocessor, at a time with the help of that ALU, we are going to process 8 bits binary information. So if it is a 16-bit, at a time with the help of that ALU, we are going to process 16-bit binary information. So same as it is 32 and 64. So if it is a 8-bit, what are the factors that depends on this 88? Microprocessor at a time bit capacity, processing capacity 8-bit, and also the accumulator size is also 8-bit, and progress status word and flag register size is also 8-bit, and also data bus length is also 8-bit. These are the factors that depends on the bit length. If it is a 16-bit, the microprocessor bit capacity is 16-bit processor, and also same as it is, the accumulator size is 16-bit, and flag or progress status word length is 16-bit, data bus length is also 16-bit, same as it is 32 and 64. So coming to the second case, that means control unit. So control unit is used to generate the control signals. What are the control signals we are going to generating? So mainly that means read control signal, that means write control signals. So not only these two control signals, with the help of bus controller device, we are going to generating different control signals. That means IO read, IO write, memory read, memory write, instruction fetch, interrupt acknowledgement, different control signals we are going to generating with the help of control unit. Inside control memory is there. With the help of that control memory, we are going to generating control signals. Here read operation means we are going to reading the data from various sources. What is meant by read operation? Reading the data from the either memory locations or registers or input devices. So what is meant by write here? Write means in the sense we are going to store or insert some data content to the various sources. Where various sources we are going to writing the data inside the memory location, or writing the data inside the registers, or writing the data into the outside devices or external world. So coming to this one, last one, memory. So memory is the storage space of the computer. Storage space of the computer which stores the different programs and also data. That means it is a storage space of the computer which stores the programs and also data. So generally memory is classified into two groups. That means one is primary memory and also secondary memory. Primary memory means represents RAM and ROM, and secondary means which represents the auxiliary memory. So primary memory has some fixed sizes there, but there is no fixed size for secondary storage memory. So then that means size is infinite for the secondary storage. It has some fixed size. It has some fixed size, primary memory. So coming to the last point, that means it performs operation like instruction cycle. So instruction, what is meant by instruction? Generally, the definition of the instruction means we are going to instruct to the definition of the instruction. The instruction is it is a command which is used to instruct to the processor or computer to perform specific task or action. That means it instructs to the computer or processor to perform specific task or action. That is called instruction. So instruction cycle means every instruction must be follows these three cycles. That means fetch cycle, decode cycle, execute cycle. The general representation of the flowchart, so it starts and fetch cycle. That means second decode cycle, and the third one execute cycle. After completion of execute cycle, the cursor goes to stop. If it is not a final instruction, again cursor goes to initial state. So let us see. That means this is a flowchart. Initially, see here program representation. This is the one program. Inside program we are going to consider different instructions are there. So every instruction is stored inside one memory location. So here first fetch and decode and execute. Suppose if you want to executing this instruction, it must be follow all these steps. So initially that instruction fetch, the instruction is followed fetch cycle. What is meant by fetch? Fetch means we are reading this instruction from this location. Reading in the sense that is called fetch cycle. After reading, again the processor goes to perform the decode cycle. What is meant by decode cycle? Decode in the sense we are going to decoding different fields. Actually, inside fields of the instruction is opcode and operand. So that means we are going to differentiate these two fields and also sometimes address fields also. Inside operand we are going to identify different address fields also there, so that we are going to differentiate opcode and also operand fields. After decode cycle, again the processor goes to the execute. So in the execute cycle, the ALU comes into the picture. ALU comes into the picture, it will execute the particular instruction. With the help of ALU, we are going to perform that decoded fields of the instruction. After completion of the execute, again processor goes to the next cycle, fetch. Again it reads, or fetch in the sense, again it reads the second instruction from the memory. Again fetching, again it will process to the next cycle, that means decode. We are going to differentiate all these fields, opcode and operand. After decoding, cursor goes to the third step, final step, execute cycle. With the help of ALU, we are going to executing the particular instruction. So after completion of the second, again this fetch cycle reads the third instruction from the memory. Like this, we are going to fetch, decode, execute. It must be follows all these three steps. So if it is follows all these steps, then only you can say that directly the one particular instruction is completed. Otherwise, the instruction execution is not completed. So like this, we are going to performing it performs operation like instruction cycle. These are the points we are going to discuss it in the definition of the microprocessor. Thank you.